Okay, so I'm Roman from Walnut.dev. We're working on debuggers, compilers, and my talk is about debugging Solidity. So this is from the recent Solidity survey. It came out in April this year. There was this question like, what are the biggest problems with Solidity, or which feature would you want to see next? And what struck me, no. Okay, what struck me was the fact that better debugging tools are second. Yeah, I'm not sure if you see the light, but they're right here. So Solidity is around 10 years old, and still developers are asking for this kind of basic thing, such as debugging. So my talk is split into 3 parts. Unfortunately, I can see that there are no animations, but we'll survive. So in the first part, I'll show you the best debugger you've ever seen for Solidity. I'm very keen for feedback, either here on stage or afterwards. So if you have some thoughts, or if you don't like it, or if you like it, please come and speak. We're very keen to improve it. But as we're building this debugger and trying to solve this problem of Solidity not having great debugging tools, we discovered some challenges. So I'll speak about that in my second part. And lastly, I'll share some proposal from improvements, because those challenges, they are not just for us, but once solved, they might improve debugging across the ecosystem. Okay. So let's first check how debugging looks today on Solidity. Okay, so this is like a setup of an engineer. On the left, they can see they have the app they're working on. They're building a D app. Here is a Anvil running. My example is on Foundry Stack, but we would like to explore also making it work for Hut. And on the top right, there is VS Code. So this is the contract this developer is working on. And here is how they can debug things today. So they would click in the D app. They would initiate some transactions. They would see them logged here in this terminal. At some point, they will see something like this, like the transaction was rejected. So now what this developer needs to do, they need to think which action caused this failure. They need to go back to UI, try to replicate, do the same set of steps, and then go to the code, put some logs. Yeah, that was this. Put some logs, and try to replicate this whole thing, hoping that the execution is going to hit these lines, and they will see this logged in the terminal, and that they will be able to fix it. So I asked ChatGPT, at what point did software engineers get tired of console log debugging and started implementing visual step-by-step debugging? This is general stuff, not just Solidity. And the answer, not surprisingly, between 60s and 70s, people were using console logs. Around 70s, 80s, that's where first visual debuggers started to pop up. So I think with Solidity, we are somewhere here. We're on the verge of going from console logs into visual style debugging. Okay, so now the demo. Same setup. This is the UI. Here, VS Code. We don't need the terminal running. I mean, Anvil is running in the background, but the developer doesn't need to have it on their screen all the time. As you can see, this is in debug mode. So there is a indication that the debugger is launched. It's using SolDB, our CLI-based debugger. What I'm demoing is a VS Code adapter plugin. And take a look at this section here. This debugger is attached to Anvil, and it's listening for transactions. So this can serve as a little local explorer. So when the developer is making actions here in the UI, the transactions are going to get logged. So, and you can see the icon. It indicates whether the transaction failed or succeeded. And you can see like the hash and the entry point decoded. So now let's go through the same flow as before and see how the debugging would look here. So we're going to make some actions in the UI. So the developer is like clicking vote, going next, vote. Now new transaction popped up. Everything is looking good. Again, clicking vote. Oh, something weird happened. Like there is an error, failed transaction, and the pop-up did not disappear. It should have. So what can we do? Well, as you might expect, we can just go and put a breakpoint to that place. The developer doesn't need to replicate the UI sequence second time because the transaction is already logged. And they can, OK, the breakpoint was set, and they can go down, and there is this little play button. And they can replay the transaction locally. They can debug it. So here I can hit play. And now we are in debugging mode, and we can go next and next. Obviously, there are variables, so it's all like what you would expect. So this is the demo. It's available on GitHub. You can go try it yourself. I'm not going to continue with those steps, but I'll talk about them in my second part of the talk, which is the challenges. All right. So just to sum up, this is the debugger. It works locally and remotely. You can attach it to your local node, but you can also attach it to, if you're building a rollup or if you want to debug something on chain, you can give it a custom RPC. It works with local source code, but we can also pull code from Sourceify. So this really would enable debugging anything on any chain if the source code is available on Sourceify. OK, now the challenge. The challenge is in mappings. So I didn't tell you at the beginning, but we tried to build this debugger based on ETHDebug, which is the new format, only on the ETHDebug. We didn't want to use the source maps generated by older versions of the compiler. And the mappings are just not there yet. So I'll talk about that now for a second. So very high level, how debuggers work. The compiler takes Solidity code, and it generates two outputs. One is the executable, and second is debug information. Okay? And the debugger needs to consume both of those files and do mapping. This debug info, this file, is critical for debuggers. Like, it needs to contain a lot of information that was lost throughout the compilation. And it's not great today when it comes to debug info generated by SolC. But what do I mean by that? So I'll skip these 2 slides. OK, one more point about debug info. So we're seeing new compilers pop up in this ecosystem. There is the new SolC, the old SolC, Solar, and SolX. And all of them need to generate this debug information so that debuggers, such as Tenderly, SolDB, which is the one we are talking about here today, or EDB, a new cool debugger out there, so that all of them can consume it. And it's very important for this debug info to be standardized. And here I would like to give a shout out to Gnidan for his work on this. Like, this is very important for debuggers. Like, to have one standard that every compiler is following. Otherwise, we would need to do custom integrations with every compiler, which would be very painful. So this is very, very good and very important. Now, I told you that the ETHDebug generated by SolC today is not very good. So, like, the question is how not very good? Like, can we quantify it? Can we give it a number? so that can we build one single KPI and run it through and generate something like this compiler with this version generated ETHDebug at level 5 or something like that. Like something similar to what we see in rollup stages, right? This L2Beat team came up with really nice simple numbers, 0, 1, 2, so that all of the rollups now can aim for the same goal. So it would be nice to have something like that for ETHDebug. And we tried to come up with something. It's pretty early, but should give an idea. So this is the second repo I would like to show to you. It's called Solidity Compiler Benchmarks. And what it does is it takes, as an input, it takes a list of contracts. Currently, there is only 5, but we can configure it to take many contracts. It can take everything from Sourceify, for example, or some subset of contracts from there. Compile it, and then run some checks. And we implemented 2 checks so far. One is the line coverage checks. And in here, we basically look at each line in the source code in Solidity, and we check if this line is represented in ETHDebug generated. If yes, it's good. If no, points down. Then we do second check, which is variable location tracking. So similar, we look at the source code at each variable, and we check if it's represented in ETHDebug. We have support for all 3 compilers and multiple versions, of course. It's CLI based, so it can be integrated into some automation. So with each new compiler version, we can generate a little report so that if there is a regression in ETHDebug, the development team know that they need to improve. Because it's important to realize that debug info generation is it's an ongoing thing. There is work on compiler on improving it, but with each improvement, the debug info also needs to catch up. Okay, so I'll now show the output that is generated by this benchmarking tool. So this is how it looks. You call it bench.py compilers, and you pass all of the compilers you want to analyze. So here we're passing the latest Sol-C, but also the legacy one, Sol-X and Sol-R. And it's analyzing 5 contracts, which is coming from some config file. And it does this to checks. And here you can see the quality of ETHDebug. So if we look at the latest compiler with via AR, the line coverage is 80%. It should actually be 100 because one of those 5 contracts is using Pragma with some old compiler version. So that doesn't count. So line coverage is pretty good with ETHDebug on the latest. Everyone else is 0. When it comes to variable location tracking, everything is 0 at the moment. So that's the state of ETHDebug. Just to sum up, it's a very important standard, but it would be good to improve it a bit. The generation, I mean. Okay, so just to summarize, the community wants better debugging tools. Like we see users or developers asking for better debugging tools, and we also see teams like us building debuggers. So the interest is there. Solidity compilers currently emit not amazing debug info. And I would like to urge to align on some benchmark so that we can at least talk about improving it. And I understand it's going to take a while, but I think this could be a good start. We proposed 2 checks, but obviously more can be implemented. We would love to get into discussions on this and to contribute. That's my talk. Thank you very much. Here are all the links.
Thank you so much, Roman. That was a very insightful talk. We have 2 questions from the app, but in the meantime, if you haven't posted your questions yet, please scan the QR code to post your questions. The first one is, what RPC node requirements does Walnut have?
We're using, so for the demo that I just showed, it's using Anvil. So it was just built on Anvil. That's the current situation.
Okay. Any plans to support Vim or NeoVim?
Yes, good question. So the way it is architected right now is there is this CLI-based tool called SolDB, which is kind of like GDB. It's CLI-based, it's very low level, but that's where the brain of the debugger is. That's where most of the work sits. And then, when it comes to Visual Studio Code or NeoVim, we just need to build adapters. But that's much simpler when compared to the brain. So, like, we can prioritize it. If someone, like, whoever's posted a question, hit me up. But it's not that crazy to do that, to like implement it.
Sounds good. Do you have workflows for debugging read-only operations like ethcall?
I'm not sure I understand the question.
Does the person who asked this question want to clarify? That's Nick.
Yes. Ah, okay, okay. So the question was not to debug transactions, but things like balance off. No, we have not thought about that. Sorry. Yeah.
Thank you so much, Roman. That will be all.
Thanks a lot.